So if you don't have it out, I'm going to grab my copy of it right here. Let's see if I can drag it. There we go. You need your unit circle. I am going to go with the coordinate method because I know that that's what this particular class prefers. My other one kind of goes back and forth. Some like the triangle, some like the coordinates. We're going to stick with coordinates because we got to learn it well, at least one way. We can learn a lot of ways, but at least one way. And this way works when it's very consistent. So it's giving us some information here. It's saying, hey, we need to figure out what cosine is. So they're asking us to find cosine. But what we know about the function is that the sine value is 1/2, and we're in quadrant 2. Okay, good morning, April. So we're going to go to quadrant 2. So quadrant 2 is right here. Okay. And I am going to look for where this sine is equal to 1/2. Can you all tell me in the chat, is the sine the x coordinate or the y coordinate? Sine x coordinate or y coordinate? All right, it is the y coordinate. So what I'm going to do is I'm going to look at my y coordinates in here. Oh, I hit it right there, right? That means I'm working with the 5π/6. So I notice that my y coordinate is 1/2, and so I have to get the matching cosine value. So the cosine of theta equals -√3/2. There's not, you might write down that your theta is equal to 5π/6. That's a good indicator to me that you understood and you actually used your unit circle. There's not much I can write down for work, right? So a lot of our work when we go into this test next week is there's a lot of work that you're doing with your unit circle, okay? And again, right now, more important that you understand how to use it. We'll deal with memorizing it later, okay? We can make that like the challenge for the last week of school. Who can get it memorized the fastest? Okay, so we are going to now talk about example 17. All right. Example 17 is a little bit trickier. What on earth did I did something really crazy with it last year. We haven't talked about that, so I'm not going to do it that way. All right, so we are supposed to be finding, we're starting with cosecant. We're looking at tangent. So this one we can't do using the unit circle because they didn't give us a radian measure, right? We're going to have to use triangles. So I'm going to draw myself a graph, and I'm going to draw myself a triangle in quadrant 3 because that's what it tells me, right? Quadrant 3. This is my reference angle right there. All right. So now when we do triangles, we put our brains back into opposite, adjacent, hypotenuse. Okay. So we're back in that world. So when I talk about cosecant, what is that trig ratio in the terms of opposite, adjacent, hypotenuse? So what do you guys think? What is cosecant in terms of that? All right, nice work. It's hypotenuse over opposite. So I know that this has to be the hypotenuse and this has to be the opposite. We also talked about that our hypotenuse is never negative, okay? And so my opposite has to be -5. Does anybody know what should my other leg be here? So what should this missing leg that's in that X direction be? What should it be? Tell me in the chat. What do you think? Be careful, because I think you might know it, but there's a little bit of a sign issue. Think about what direction we are. All right, see, good old Pythagorean's here, and rears his ugly head, or his beautiful head. It was Mrs. Ballard's class, right? All right, so we know that it's 5, 12, 13. We could have that memorized, right? It's one of the triples. We know that it's got to be a 12, but because it's directionally to the left, it's got to be negative. And think about that. The X and the Y are related to sine and cosine. Aren't sine and cosine both negative in quadrant 3? Okay. So now that I have my triangle, I'm going to find the tangent of that triangle. So the tangent of theta equals my opposite, -5, over my adjacent, -12. And lo and behold, guess what? It's positive, right? And we're in quadrant 3. That's no surprise to us that it's positive in quadrant 3. Okay? So far, hopefully not too bad. There is another way to do it. We will learn that other way after we take the test. So there's these trig things, there's like 5 million ways to do each one of them. They're all good, okay? But if you learn little bit by little bit. All right, let's look at example 18, okay? So they give us a little bit different information. Again, I did this one weird because we have not learned, I did them all with identities. We haven't learned those yet. We're going to be given the value of the trig identities to find the remaining. Okay, so the identities we've learned are reciprocals. The ones I used in this were not reciprocals. All right, so I know that there's always a 1 underneath here, okay? And let's just try to figure out what quadrant we're talking about, and then we'll talk about the easy one, okay? So it says that my cotangent is negative. So which quadrants is so think about it as all students take calculus, right? Which quadrants is cotangent allowed to be negative in? Can you tell me that in the chat? So which ones am I allowed to be negative in with cotangent? What do we think? Hoping there's a delay. At least give me a guess if you don't know. What do you need, sweetheart? What? You got a lot of points on a test?
Yeah.
Okay, good job.
Not the map.
Not the map test. Okay. Bye. Thanks for letting me know. Okay. I saw a few, like say quadrant 3, and then I see a lot of 2s and 4s, and I see a lot of impressive Roman numerals. Good job. I know that's why it was taking the extra time, because we did think through the Roman numerals, right? So let's talk about this. Remember, sine it's sine and cosecant positive, so that means quadrant 2 for sure. This one means tangent and cotangent positive, so it can't be that one, right? This one here means cosine and cosecant negative or positive, everything else negative. So it's definitely 2 and 4. All right, so now that I've picked that out, it says that my sine needs to be positive. So between quadrant 2 and quadrant 4, where are we landing? If sine has to be a plus. What do you guys think? What are we going to narrow it down to now? Where is the sine positive between quadrant 2 and quadrant 4? Remember, we're looking for the sine to be positive. All right, we're changing our minds a little bit. That's good. It's okay. All right, so the sine is positive here. So we know we have to be in quadrant 2. So I'm going to actually erase all the other stuff. Oops, not highlight, erase all the other stuff. Okay. So we know that we're going to be in quadrant 2. In fact, I'm going to erase that. I'm just going to draw my triangle in quadrant 2. Okay. All right. So before I even set the triangle up, it says that it wants me to get the remaining trig identities, or the trig functions of the angle. What is the reciprocal of cotangent? So I'm talking about, like, is it sine, cosine, cosecant? Which one of those is it? What's the reciprocal of cotangent? All right, you guys have learned that this week. That's really good. Okay, we're getting that down better. Good job. Good job. All right, so that means I get that one for free, right? That's my freebie. So tangent of theta equals -1/5. Yay! Okay, so I can either go off of tangent or cotangent. It doesn't matter. I know that the 1 has to be opposite. The 5 has to be adjacent. I don't know which one's negative yet. I'm going to have to look at that directionally when I get there. So opposite is 1. Adjacent is 5. This is not drawn to scale. Okay, so looking at that triangle, because we've decided quadrant 2 is I want to look for the the number that's in the negative direction on the graph. So which number would be in the negative direction on that graph, the 1 or the 5? What do you guys think? You guys are awesome. It's going to be the 5. All right, we're going to have to get out good old Pythagoras, aren't we? We need to figure, because I can't do the other ones until I figure out the hypotenuse, and it's going to be some radical, okay? It's going to be really radical. So 1 squared plus negative 5 squared equals, we'll just call it r squared for now. You call it whatever you want. You want to make it smiley face squared, make it smiley face squared. It does not matter. All right, so 1 squared is 1, 5 squared is 25 equals r squared, so 26 equals r squared. Again, we're going to keep it positive, so it's the square root of 26. All right, we're back down to, we've done this, we're starting to get to the point where we've done this like a million times, right? So let's see, sine of theta would be the opposite 1 over the hypotenuse squared of 26, rationalize it. I should, before I rationalized it, I should have done my flip, huh? So I know that cosecant is going to be the flip of this. Square root of 26 over 1, or just 26. I'll give you a couple seconds to catch up. That will be the benefit of Monday, is when we go back, I know when people are done writing it again. Maybe. Unless whoever's in the classroom is a fast writer, huh? Oh, okay. Apparently there's a scheduled power outage in the area somewhere today. That's nice. All right, cosine of theta equals, all right, the adjacent negative 5 over the hypotenuse square root of 26. I'm going to go ahead and flip my reciprocal now so I don't forget about it. It doesn't matter where that negative floats, so square root of 26 over 5. Rationalize again. Negative 5 over 26, square root of 26 over 26. While you are waiting for others to catch up, I don't know. They just emailed. It might not be us. I don't think it was us. They just emailed and said, scheduled power outage in their area today. Multiple calls this morning letting us know. Students in that area, but not. So it's not, I don't think it's us, Lauren. It's not windy. I was worried yesterday because of the wind. So I know we get them all the time in this neighborhood. It's ridiculous. I still don't, I think they finally fixed the one pole. There was a pole out by the cows that they fixed. Mrs. Artifer was worried because it's over, her house is over there by the poles. So she's like, do I need to worry that pole gonna fall in my house? Okay. Let's take did we all get anything to double enough? All right, the next piece is calculator work, okay? We kind of talked about this the other day. We got to make sure that we're in the right angle mode. So it is a degree mode if you see the degree symbol. If you don't see the degree symbol or you see a pi, it's in radian mode. So look at this one here. No degree symbol, you need to be in radians, okay? Pi, radians. So this is the only one that gets to be in degrees. I know we are using whatchamacallit, we've been using Desmos, okay? I think our first like 2 or 3 days back, because we'll probably have you check one out from the library. Like the first couple of days, we're going to learn how to do the TI Inspires next year. So, because we got to learn them fast in calculus. We don't use them a ton first semester, but second semester we do a lot. All right. So let me go in. I'm going to get into Desmos here, and I'm going to do this with you really quick. I'm probably not going to write down a whole lot. So with our first one was cotangent of 410, but that's not the right answer, right? Because we were supposed to be in degree mode. We have to look, and remember, Desmos defaults to radians, so we have to switch it to degrees. So our answer would be, it looks like I don't need to round even, because it would go to a 0.839. And make sure you're getting it the right number of decimal places. Okay, oh, we put a little tag from Desmos. Wasn't that nice of them? All right, the next one is in radian mode, so it is the sine, and I'm going to use parentheses, of -7, but again, that's degree mode. I need to flip this back into radian mode. So we're going to, this one would now be, oh, it looks like I'm going to have to round up, right? So 5/7. So it would be -0.657. Okay. All right, last one. All right, the last one, I totally lost what function. I'm doing secant of pi divided by 9. What's really nice about like today's calculators is they actually have the reciprocal functions in them. When I was teaching 20 years ago, our calculators didn't have that in it. You only had sine, cosine, and tangent. So they've come a long way. Again, I'm going to double check my mode. I'm supposed to be in radians, so this is good. It does look like I'm going to have to round a bit. So let's see. Oh, of course, I put it right where I can't read it, right? So 1.064. Oh, I guess I don't have to round. Never mind. I was looking at I missed the 0. All right, so easy peasy lemon squeezy. We can handle all of the calculators, right? We'd like all calculators on the test. All right, here's the ones that get tricky, okay? And I'm going to kind of phrase this in a way, maybe not. Let me have that. Can I just get to an arrow, please? I want to grab my, it's being silly. Okay, hang on, I'm going to close and open again. That usually gets it out of that. All right, there we go. I'm going to drag this down here a little ways because we're going to need our unit circle on these. So what we've used the unit circle for at this point is we have used the unit circle to solve for exact values, okay? And we've used them to solve for, we're using mostly with the coordinates. We've been given an angle and we find the coordinate. Now we're going to go backwards and we can use it to solve for an angle, all right? So that's what we're going to do now. We can do this in degrees. I'm going to focus on the radians. We'll kind of convert to degrees. You can read me your degrees, but it doesn't matter, right? They're all, the degrees and the radians are both marked on your orange unit circle, right? So you'll be fine. All right, here we go. Right, so 2 solutions to the equation. Give your answers in degrees and radians. Again, I am not, and it says don't use your calculator. I'm not looking for, I totally lost what I was going to say. All right, let's look at the cosine of pi square root of 2 over pi. Oh, sorry, square root of 2 over 2. I'm apparently losing it. All right, so is the cosine the x coordinate or the y coordinate? Can you tell me that in the chat? The x coordinate, is cosine the x coordinate or the y coordinate? Okay, perfect. It's the x coordinate. Okay, so I am going to go around my unit circle and I am going to find every radian measure where my x coordinate is square root of 2 over 2, positive square root of 2 over 2. So it has to match exactly. So I'm going to say theta equals, all right, I'm looking for, I always start at 0, right? That's kind of our beginning. So I'm starting there. Oop, here's 1. So I'm going to grab my radian measure, which is pi over 4. I'm going to keep going. Oh, can't use that one. It's negative, right? Keep going. Can't use that one. It's negative. I'm traveling around my unit circle. Oh, here we go. So I get to use this radian measure, 7 pi over 4. There will always be 2 answers, right? Because there's always 2 places where each of the trig functions is positive, okay? Or each of the trig functions is negative because there's only 4 quadrants. All right, so in degrees, let's see, 45 degrees and what's this one? Tell me what's 7 pi over 4. Read it to me off your unit circle. Is it 225? No, yeah, 225, right? What are you getting for, what else is it 7 pi over 4 in degrees? Nobody can tell me? There, oh, 315. I'm off. I'm in the wrong quadrant. I had quadrant 3, didn't I? Good job, everybody. 315. Thank you for proving me wrong. It's okay. I'm not always right. Okay. All right. Unless I'm mom and telling them my kids what to do, right? Then mom is always right, right? Even when she's wrong. All right. Mother's Day, you've only got like a couple weeks. If you haven't shopped yet, start now. Make a very meaningful card starting now, right? You've got a lot of time still. Okay. Here's what I want you to do. Okay. I want you, we know that you guys have already told me this is the x coordinate, right? Don't type anything in the chat yet. I want you to travel around the unit circle, and I want you to find 2 places, 2 radian measures where your x value is negative square root of 2 over 2. Put that, don't type it in the, you can type it in the chat, but don't hit enter yet. Okay? So I'm going to give you a minute, travel around the unit circle, find 2 places. Okay, you can either hit enter or type it in the chat now. Tell me what you think. What are 2 places you found where we have negative square root over 2 over 2 in the x value? Oh, I like that Lauren did degrees because we were going to need that anyways. I was looking for radians. That's where my brain always goes, but I like the degrees. Thank you, Lauren. Okay, so I'm looking here. I'm seeing 3 pi over 4. I like that one. And I'm looking here, and I'm seeing 5 pi over 4. So 3 pi over 4 and 5 pi over 4. And then WebAssign is going to ask you for both. Lauren was kind enough to tell us 135 and 225. Okay. All right, we're going to have another one. So this next one is a little bit more challenging. Okay, so what we have to think about is the reciprocals now. Okay, so for 24. So I know that this is always going to be the fraction 2 over 1. Okay, there's always a 1 in the denominator. What is cosecant the reciprocal of? Tell me in the chat. What's cosecant the reciprocal of? Okay, perfect. It's the reciprocal of sine. So I'm going to rewrite this because I also know that this is the sine of 1/2. Is 1/2 the x coordinate or the y coordinate? I only got about 6 people that time. All right, so we're gonna walk around our unit circle, and I'm walking, and I'm going to find anywhere where my y coordinate is 1/2, and I'm going to write down my radian measure, which is going to be here at pi over 6. I could do my degrees at the same time, right? That's 30 degrees. Okay, I'm going to keep walking. I know there should be 2 places. I'm looking for my y coordinate. Oh, look right there. So 5 pi over 6. Which I believe is 1. Oh, I'm writing it in the wrong spot. Boy, oh boy. 5 pi over 6, which I believe is 150 degrees. And that's it, right? There should only be 2. If I keep looking, these ones were negative, so we're good. Okay, hopefully making sense. Again, we're reversing our coordinates today. We're trying to find those angle measures. All right, cotangent's a little bit trickier. All right, so you gotta bear with me and watch me how I build this back up. Okay. I know what's always in the denominator if there's nothing there. So it's always in the denominator if there's nothing there. All right, perfect. So I know I could add a 1 in here, and I'm not worried about anything else yet. What's the reciprocal of cotangent? Because I know, actually, never mind. Don't need that. Never mind. In terms of sine and cosine, how would I write cotangent? So in terms of sine and cosine, how would I write cotangent? What do you guys think? It's what divided by what in terms of sine and cosine? There's only 2 choices. Okay, perfect. You guys are doing good. It is the cosine divided by the sine. So I know that I've got to find the cosine divided by the sine. So guess what? They actually gave us the exact coordinates this time. Okay, well, almost the exact coordinates. What do you notice in the unit circle that is the denominator on absolutely everything? So what's the always denominator in the unit circle under every single coordinate? Yeah, I've got a 2 everywhere. Remember how we were crossing them out before? Well, we're going to reverse that. So what this is saying is that I really have negative square root of 3 over 2 and then 1/2. Or I could have square root of 3 over 2 and negative 1/2. So that translates to 2 coordinates. Okay. Remember, if it's the cosine divided by the sine, my numerator is my x. So I'm looking for the coordinates negative square root of 3 over 2 1/2 and square root of 3 over 2 negative 1/2. If it had been tangent, I would have had to reverse my numerator, my denominator for my sine and my cosine. Okay. All right, so I'm going to look for those, and I'm looking for both the angle, the radian measure, and the whatchamacallit, and the degree measure. So negative square root of 3 over 2, positive 1/2. Oh, look, here it is. That's the exact coordinate. 5 pi over 6. Oh, what am I doing? 5 pi. Oh, come on. 5 pi over 6, or 150. And then let's see. I need to find positive square root of 3 in the x, and negative 1/2 is right there, 11 pi over 6. Or let's see, 330. Make sure my degrees are right.